Good morning, students. So now there is a new chapter. That's chapter name is motion in a straight line. Motion in a straight line. So before going to discuss about this chapter, motion in a straight line. So in general, which we can classify the mechanics as two types. One as a kinematics and one as a dynamics. So in kinematics, this which we can define here as this kinematics is the part which will discuss the motion of an object. So it will describe the motion of an object without considering the cause of motion. So this kinematics which will describes the motion of an object. So without considering the cause of motion. So in order to move an object, we should have applied some force. Regarding that force, it is not going to consider. It's only described about the motion of an object. So in motion, you have been taken which we can classify that's divided into majorly three parts. So one is along one dimensional. So one dimensional motion. Two-dimensional motion, and three-dimensional motion. So apart from these motions, we are not considering about the two-dimensional, three-dimensional. Here we are going to explain about the one-dimensional motion. So what are the examples for this one-dimensional motion? If an object or a particle, in kinematics we are considering object as a particle or a body also it can be considered. So in one-dimensional motion, examples which you can take here as example, walking a man. Along straight route, along path. So for two-dimensional motion, so which you can take example here as example is so object moving in a circle. So object moving in a circle. So whereas for three-dimensional motion, which you can take here as flying bird. Flying bird is an example which you can take. So but our chapter is regarding the motion in a straight line. We are going to discuss only the one-dimensional motion. This one-dimensional motion it is also known as rectilinear motion. Rectilinear motion. This rectilinear motion is nothing but whenever an object is moving along a straight line. Such kind of motion you can take it as a rectilinear motion. So before we discuss about this chapter, here we are using motion. So and then straight line, everyone knows, whenever an object is moving on one particular path along the x-axis, y-axis or z-axis. So here motion, before going to that, we should have to know regarding rest and motion. So when we can call an object is said to be at rest, when we can call an object is said to be at motion. So the definitions I need to explain. So regarding first, we are going to discuss regarding rest. When we can call set rest, an object is said to be at rest. An object is said to be at rest. Said to be at rest. At rest. It does not change its position. Change its position. Change its position with respect to time and fixed point. Fixed point. In such a case, we can call it as an object is said to be at rest. So, for example, so you have been taken any object. So, refrigerator or fridge you have been taken, that it will be in one position. So, even though time passes also, the position of the refrigerator it does not change. And with respect to fixed point, here fixed point is nothing but surroundings. So next, motion. So when we are going to call it as a motion. So simple, an object is said to be in motion. It changes its position with respect to time and fixed point. So an object is said to be in motion. If it changes its position with respect to time and fixed point Here what is the meaning of fixed point is? Fixed point is nothing but surrounding area which you can take. So for this example you can take a person. If a person is standing at one place, at that time we can tell here as that person is at rest. But after some time what he will do? He will try to change its position from one place to another place. At that time what it will be happen? It changes its position with respect to time, wherever the time will changes along with that fixed point. For example, now I am standing here, now I am at rest with respect to time and with respect to surrounding area fixed point. When I can call it as motion, so whenever as a form I can call that now I am in motion. So that is motion. So based on this we can give a small relation that which is nothing but so rest and motion are relative with each other. relation with each other. So what it will represents. So now with respect to this reference frame, with respect to this fixed point, now I am at rest. For example, you have been considered Earth for all of us with respect to our frame. Earth is at rest. But whenever if you go to space and then you have been observed that, as if all us knows that Earth rotates about itself. So that with respect to frame, whenever the frame it has been changed. So we can tell in some conditions we can tell here as object is at rest. With respect to some other reference frame we can tell it as object is in motion. So because of that, rest and motion are related with each other. The simple example which you can tell. If two trains which they are moving same speed, 40 kilometers per hour, 40 kilometers per hour, along the same direction. So whenever the two persons are seen from train A and train B, so they appear to be at rest. But the third person who is standing in station, they can see that both the trains A and B are in motion. So like this, here we can do the relation. Rest and motion are related with each. This is a basic introduction regarding the motion in straight line. So in this chapter, we are going to learn different kinds of physical quantities. All these concepts, introduction part which you have been studied in the lower classes. So regarding that, physical quantities which I have taken, now we are going to discuss majorly regarding these types. So apart from that, the first one is distance. Distance is one physical quantity, and then displacement. Is one more physical quantity, and next one is nothing but speed. It is also a physical quantity. Velocity, acceleration, and final one is nothing but jerk. These are the some physical quantities which we are going to learn so majorly, and then we should have to keep it in mind. Most of the students which they may have been confused regarding distance and displacement. So what's the difference between distance and displacement? So it appears to be same, but in exact there will be some difference. In the same way, speed and velocity and acceleration. So these are the basic physical quantities which we are going to use in class 11 as well as class 12. So regarding that, now I am going to discuss differences between the distance and displacement. So by using all these physical quantities, we are going to find the kinematic equations, and then finally we are drawing the graphs. So based on that, we discuss later. Now I am going to discuss regarding distance and displacement. So distance. Then next one has displacement. So what is the major difference between distance and displacement? So in vectors, so in mathematics also you have been learned that we are having two types. So one is a scalar quantity and one is a vector quantity. So depending upon that, first I am going to explain the definition of distance, then displacement. So here, so first point which I can take here as the actual path length. The actual path length between initial and final positions. So here as if we are telling initial and final. So initial is nothing but starting point, and final is nothing but ending point, that which we can call it with respect to position. Now I can take here as this is my initial position. Whenever as if I am moving from here to here. So let us consider 10 centimeters which I have been moving. That is the initial position and this is the final position. So the actual path length. So what is this actual? Really, which as if has been. So for example, I have been taken two positions. So this is the A is the initial position and B is the final position. In order to move from A to B, which we are having different paths. For example, as if I am considering that one person which as if has been moved in this path as in the form of a circular path. So one more person which as if has been moved straight line A to B, and then one more person which as if has been moved like this. So these are the three different paths. So A to B, this is the actual path, A to B, this is second, and A to B, this is a third. For example, in order to move from one place to another place, for example, in order to move from Bangalore to Hyderabad, so which we can move in different ways. So from one place to another place. So in such a case, we can give it as A as the initial position and B as a final position. So example, as if I am taking, this is 500 meters. And this is a 300 meters and this is a 400 meters. So which you can consider. So based on this, the actual path line. So if a person one is moving means how much distance he has been moved means 500 meters. The second person he has been moved from A to B as 300. Third person has moved as 400 meters. So that is the distance. In this case, as you have been observed, here we are not concerned regarding the direction. We are concerned only the path. In which path he is moving. So in the same way, we should explain here as displacement. The displacement should be defined here as the shortest distance from initial point to final point, or from initial point to final point, or we can take it as from initial position to final position. So you can use a point also, nothing will be wrong. The shortest distance from initial position to final position. So here I am taking as example as like this. So please try to understand. So if a person is moving from A to B, so let us consider that this is 100 meters. In such a case, so what is the displacement? What is the magnitude of displacement we have been considered? A to B is nothing but 100 meters. Then we may ask one more question. Sir, here what is the distance? Distance is also 100 meters. Then what is the difference between the distance and displacement? Here, this distance is a scalar quantity. This is scalar quantity, and displacement is a vector quantity. When our object is moving along a straight line, in such a conditions, the magnitude of distance and displacement are equal. So for this, I am going to take a small example. So for example, here, a person who is moving in circular path A to B. So let us consider. So for this, the radius of this circle is around I am telling only 100 meters. Then it has been covered approximately, for example, so 800 meters. Now, if a person is moving from A to B, in such a case, if you want to find distance and displacement, means Distance we can tell here as 800 meters. So then what about displacement? Here the definition of displacement we have been seen. The shortest distance from initial position to final position. Here what is the initial position? A. What is the final position? B. For that straight line which we are getting shortest distance, that as if I am taking here as like this, as if I am going to get like this. So this is the shortest distance. So then what will be the displacement? Displacement is nothing but A to B. So this will be simple. Radius is R. We know for circle that length will be 2R. So from A to B is a 2R. In such a case here, displacement. So displacement is equals to 200 meters. So this is a major difference. This distance it depends upon only an actual path length between initial and final positions. But whereas displacement it depends upon the shortest distance from initial position to final position. So based on this we can check. So second part I can tell here as it is a vector quantity. It is a scalar quantity.